Hello everybody. We are going to discuss today the very first chapter of second year intermediate, that is wave motion. I am Srinivasa Charyulu. From this particular chapter wave motion, we can expect two questions in the final examination of Eamcet. Both usually be based on the basics, like most of them are formula related questions only. So far they have asked in previous Eamcet papers. So let us check one or two cases before taking up the topic. Wave motion deals with the general equations of waves, like y is equal to a sin omega t plus or minus phi. This is the general wave equation that is called a progressive wave equation as such. Out of that, a represents amplitude, sin value represents a function, omega t is called phase, and phi is called phase difference over there. Omega t plus or minus phi, total phase, we people used to call it like that. Out of that one, we can even rewrite the same this way. A sin omega can be written 2 pi by capital T into small t plus or minus 2 pi by lambda into x. Out of that, you can understand capital T represents the time period. 2 pi by lambda into x is equal to phi. In fact, there is a relation between phase difference and path difference of the wave. So this is the general equation for a progressive wave, based on which they may ask you questions. Coming to the next one over here, what is the velocity of sound in general? Any wave, the velocity of the wave whenever we want, v is equal to n lambda, we people used to take up. Out of that, n represents the linear frequency and lambda represents the wavelength. The same even can be rewritten as lambda by capital T also. Lambda as usual is wavelength and capital T gives you the value of time period of that wave as such. Coming to the next one, if it is a particle velocity, we people used to write omega root a square minus y square. That is the general equation for particle velocity as such, which of course is in simple harmonic motion. And omega represents angular velocity or angular frequency, a represents amplitude, which is also called maximum displacement, and y represents the displacement. On what factors the velocity of sound that depends, that also is one of the important aspects of this chapter. Velocity of sound is equivalent to under root e by rho when temperature remains constant. That in other words, in an isothermal material medium, according to Newton's formula, velocity of sound is square root of directly proportional to square root of modulus of elasticity of the medium and inversely proportional to square root of density of the medium. But of course, we people should understand that temperature constant is not going to be possible whenever sound wave travels through a medium, because compressions and rarefied zones are going to be formed. At compressional zone and rarefaction, generally the temperatures they vary. Due to that, it cannot be isothermal medium after the wave is entering into the medium as such. And according to Laplace's correction, we write the same as e by rho only, but that can be written as under root gamma p by rho. That gamma, of course, we have discussed in thermodynamics chapter earlier, which is now nothing other than Cp by Cv, specific heat at constant pressure divided by specific heat at constant volume. That ratio of specific heats, we represent that one by gamma as such. What is the effect of temperature on velocity of sound? Velocity of sound is directly proportional to square root of absolute temperature. This, of course, we can rewrite this one as V1 by V2 is equal to under root T1 by T2, another equation which you people have to remember. Here there is one theoretical concept also they can ask you. For every 1 degree centigrade rise in temperature, the velocity of sound, particularly in air, increases by around 0.61 meter per second. This is a result one should remember. I once again repeat, for every 1 degree centigrade rise in temperature, velocity of sound in air increases by 0.61 meter per second. So this is a direct relation. What is the influence of pressure on velocity of sound? Velocity, of course, is independent of pressure. What we people have to understand here is when temperature remains constant is the condition. If the temperature of the system is remaining constant, or in other words, if the system is isothermal by nature, velocity is independent of pressure, because P by rho under root is velocity of sound. If suppose pressure increases 4 times, density also increases 4 times. Thereby 4 getting cancelled, root P by rho will be left as it is. Suppose pressure becomes half, even density also becomes half, thereby 2 getting cancelled, once again you are left with root of P by rho. That means what? Pressure variations are not going to change the velocity of sound as long as the temperature of the medium that is constant. So this is one area you have to concentrate on. And another thing, velocity is inversely proportional to square root of the density of the medium. This one, of course, is one of the very important formulae for you. For example, hydrogen, oxygen, nitrogen. If I take 3 gases like this, in which gas the velocity of sound is the greatest? Suppose if they ask you, out of all the 3, hydrogen has got the least density, therefore the velocity of sound in this one is going to be maximum, and in oxygen it's going to be the minimum. So this is also one of the applications you people just have to remember. Now come to the next one, please. If you take up the concept of vibrating strings. If you take vibrating string, velocity in a vibrating string is directly proportional to under root T by mu. What is this T over here? This, of course, we used to take it as tension in the string. Tension is nothing other than weight attached to the string or the stiffness in the string. Whatever you talk about, that is called tension. And what is this mu now to be called? It should be called linear density. Remember this wording. Linear density is nothing other than mass per unit length, m by L. That is what we people used to take up. So velocity is directly proportional to root of T by mu. If I take the proportionality constant as 1, like, we can even write V is equal to under root T by mu, the formula. Then what will be the equation for frequency? It is V by lambda. That, of course, 1 by 2L root of T by mu. This is the formula that is to be taken up whenever we take any model question based on sonometer as such. And of course, this is the case which we take up when first harmonic that is going to be formed over there. Suppose if that fellow says nth harmonic or pth harmonic. Pth harmonic, P is the number over there, maybe 7, 8, 9, whatever the number be. That time Np can be written as 1 by 2L. That 1 should be written as P. P by 2L under root T by mu. That is the formula one should remember over here. So this is the formula by means of which any problem that comes on sonometer, just like that you can work out. Now come to the last point over here. The same velocity you can even calculate in the case of air columns. Air column, when you consider what kind of a wave that is going to be formed in an air column, certainly it will be a longitudinal wave. It may even be stationary sometimes or progressive some other times. Whatever it is, stationary longitudinal waves are going to be observed in the case of tubes or pipes. This is what we call it as a closed pipe. In a closed pipe, what will be the way of taking the frequencies? N1, the first harmonic frequency, which is V by 4L. N2, that of course N3 we write it 3 times V by 4L. That is called third harmonic, or you can call it first overtone. You can understand well, in the case of closed pipe, even numbered harmonics are not possible. So if you take the next one, N5 is equal to 5 times V by 4L. That is officially taken as a second overtone. Means what? N1 is to N2 is to N3 and so on will now be 1 is to 3 is to 5 and so on. That means what? No question of getting even numbered harmonics. Another point here to be remembered, if I draw the figure for first harmonic, one node and one antinode are formed. For third harmonic, you will be getting 2 nodes and 2 antinodes, means number of nodes is equal to number of antinodes. That is one more point you people have to understand in the case of a closed pipe that is closed at one end. Suppose if you consider the same in the case of an open pipe like. Open pipe or open tube when we consider, directly you will be getting antinode formation at the open end, and of course one node you will be formed in between, that is somewhere here. The reflection takes place somewhere below this one, therefore anyhow we can understand stationary wave is going to be formed again. So what will be the frequency over here? V by 2L, that is called first harmonic. This is the formula. Suppose if I take the second one, 2 times V by 2L, this is what is called second harmonic, or you can call it as first overtone. These are the things you have to remember. So if I take simply the ratio of all these frequencies in the case of an open pipe, 1 is to 2 is to 3 and so on, means what? Both odd harmonics are possible as well as even harmonics are possible in the case of an open pipe. So these are the areas on which we people are taking up few applications based on this chapter wave motion today. Let us take up some of the applications of this topic, please. Let us consider the very first problem what has been given over here. A progressive wave of frequency 500 Hz is traveling with a speed of 330 meter per second in air. The distance between the 2 points which have a phase difference of 30 degrees is how much? In fact, this question can be solved by taking up relation between phase difference and path difference. 2 pi by lambda into x. This phi is called phase difference over here, and this x is called path difference over here. But one should understand this wavelength lambda is going to be V by N. You can take that one also. Now what is the question he is asking? What is the distance between the points? That means what is the path difference? X is equal to lambda by 2 pi into phi. But of course, what is the value of phi given? 30 degrees. So you can write lambda by 2 pi. 30 degrees can be written as pi by 6. Now pi getting cancelled, you are now left with lambda by 12. Fine. But what is lambda? Lambda is going to be V by N. What are the values given? You see, 330 by 500. That is actually the value of lambda. Now simplify this one. X is equal to 33 by 50 into 12. Whatever the value you will be getting, directly you can take so many meters is going to be the corresponding value. You will be getting this value 0.055 meter as such. That will be the corresponding value over here. That means the fourth option that's going to be true. And remember this formula thoroughly. Phase difference is equal to 2 pi by lambda into path difference. That is the relation based on which the very first problem has been based now. Let us check the second problem now. That problem says the frequency of a tuning fork is 256 Hz. The velocity of sound in air is 344 meter per second. The distance travelled by the sound during the time in which the tuning fork completes 32 vibrations. One of the excellent model questions this one is. 32 vibrations. Understand first of all, one vibration means one wave that comes out. That means it is equivalent to 1 lambda the distance. Now if you take 32 vibrations means what will be the total distance over here now? 32 lambda. Therefore what you should understand? Distance travelled is equal to 32 times lambda, which now can be taken 32 into V by N. What is the value of velocity that is given? You check there. It is 344 that is given over here. By what is the frequency that has been mentioned? 256. This has been given like this. Now check this one carefully, 32 over here, 340 for this one. You can cut 4 over here. How many times? 6 times, 4 times. Now here also you can cut 4, right? 8 times. Now this goes exactly 8 times once again. So you can once again cut 2 times 4. Here 8 times and 6 times. So what will be the value? 43 meters is going to be the total distance traveled by that. That in the sense we can say the second option is going to be correct for this particular question. Remember carefully, number of vibrations made by the tuning fork is equivalent to so many waves over there which are being formed. 32 vibrations means 32 wavelengths they will come out. That is the total distance traveled by the wave that has been emitted by that. Let us check the next number, that is problem number 3 here. Check that one. A uniform string of length 1.5 meter has 2 successive harmonics of frequencies 70 Hz and 84 Hz. The speed of the wave in the string in meter per second is how much? Just now I have reminded you in the case of a sonometer, where a string is made vibrated with different harmonics. You can understand N1 will be 1 by 2L root T by mu. N2 will be 2 by 2L root T by mu and so on. Means what? 2 successive vibrations, if you take the frequencies, that will be the initial frequency itself. That is what is called fundamental frequency. So what will be the value of fundamental frequency over here now? It is the difference of the frequencies 84 minus 70, which now is going to be 14 Hz. That is the value. And of course, a uniform string of length 1.5 meter has been given. The speed he is asking you to calculate. V is equal to n lambda, general formula. Of course, we all know that one very well. But what is the value of length given over here? In this case, fundamental frequency means this must be the length. That is equal to how much? Lambda by 2. Then what will be lambda? It will now be 2L. So 2L into this value of n, whatever the value you will be getting, you can write directly. What is L value that has been given over there? You check it. 1.5. So 3 times 14 will definitely be 42 meter per second as such. So second option is going to be the correct option for this question number 3 as such. Let us check the next one please. Problem number 4. A transverse wave propagating on a stretched string of linear density 3 into 10 power minus 4 kg per meter is represented by the equation y is equal to 0.2 sine 1.5x minus 60t, where x and y are in meter and t is in seconds. What is the tension in the string is the question. One thing you should understand here, he has given us linear density. That's mu. Of course, we people are representing it with 3 into 10 to the power minus 4 kg per meter. That is linear density mentioned. Fine. But velocity is equal to root t by mu. Taking this formula, if you can calculate velocity by taking mu, you can estimate the value of t. So what is the t over here now? V square mu. That is ultimate formula. But how to get V? From that equation you have to think of y is equal to, what is that value given you see? 0.2 sine. What are the values given in brackets? 1.5x minus 60 into t. Just look at that one. What is this 60? It's omega. What is this 1.5? 2 pi by lambda. In fact, 2 pi by lambda into x by this omega into t. That is the equation what we have taken. So 2 pi by lambda, when it is 1.5, what will be the value of lambda? 2 pi by 1.5 you can take. And of course, omega is 2 pi n, you can understand. That value is given 60. Then what will be n now? 60 by 2 pi. Now you can take these two and estimate what is velocity first. V is equal to n lambda. 2 pi by 1.5 into 60 by 2 pi. In fact, 2 pi gets cancelled. 1.5 of course it goes just 40 times. So what is the velocity over here? 40 meter per second. Come on, just substitute that value over here. So what will be the tension over here is the question. 40 square 1600 into mu, that is 3 into 10 power minus 4. In fact, 2 zeros you can cut it minus 2 times. 48 into 10 power minus 2. So how much must be the value now? 0.48 Newton must now be the corresponding tension over here. Means what is the answer over there? You just look at second option is giving us the same result, 0.48 Newton as such. So for this question number 4, options 2 is going to be tallied there. Let us check the next one, that is question number 5. An iron load of 2 kg is suspended in air from the free end of a sonometer wire of length 1 meter. A tuning fork of frequency 256 Hz is in resonance with 1/√7 times the length of the sonometer wire. If the load is immersed in water, the length of the wire that will be in resonance with the same tuning fork is, specific gravity is given as 8. First thing you should understand is resonance condition is to be taken up first. What is the condition for resonance? Frequency values are going to be equal. That is the condition for resonance as such. That's one area. And secondly, he is talking about with the same tuning fork. That means 256 Hz earlier also, now also. Now the point here is you should understand what is the question that is asked. If it is immersed in water, length of the wire that will be in resonance, that is the concept what we just want. In fact, n is equal to 1/2L root T by mu. Can't you just understand L is proportional to root T over here, please? So you can understand L in air by L in water is equal to root of tension in air by tension in water. But what is the way of calculating tension in water? Just look at carefully. Relative density is nothing other than weight in air by weight lost in water. What is weight lost in water? In other words, weight in air minus weight in water. This value is given as 8. But be careful, weight and tension are exactly one and the same in this particular case. Therefore, if you eliminate this one, if you cross multiply this, W in air is 8 times the weight in air minus 8 times the weight in water. That is actually the equation. So you can even write 7 times the weight in air is equal to 8 times the weight in water. But in fact, we people are having T in air by T in water, means in other words, weight in air by weight in water, I can write. What is weight in air by weight in water now? It is 8 by 7 under root. That is the corresponding value. But you should understand what is L in air given? 1/√2. So simply write that 1/√7 into L in water is equal to root 8/√7. I can write. Root 7 gets cancelled. So what will be length in water, please? It is 1/√8 meter or 1/√8 times the length of that original value. So 1/√8 meter means the fourth option is going to be the correct option for this question number 5. One of the excellent model questions here, please. Relative density concept is taken up and is linked with the question of wave motion as such. Let us check the next problem. Problem number 6. A uniform rope of mass 0.1 kg and length 2.45 meter hangs from a rigid support. That is actually the description what has been mentioned. See, now he is talking about a rope like this. It is now hanging. This is the rope what he is talking about, let us say. Now check what are the dimensions he has given. 2.45 meter is the length of this rope given, 1. And what is its mass that is given? 0.1 kg. That's the mass of the rope given. Time taken by a transverse wave formed in the rope to travel through the full length of the rope is how much? In fact, V is equal to n lambda. We can write the same lambda by T also. So T must be equal to lambda by V. And of course, lambda in the case of a string 2L by V. what is this V now? V is equal to under root T by mu. What is the value of tension over here? 0.1 into 9.8 by, what is mu? Mass per unit length, 0.1 divided by 22.45. That is a value that has been given. You check that one. 2.45. All under root I should take. This is for velocity. Look at these two, they get cancelled. What will be this value now exactly? 4.9 you will be getting. What? Meter per second. Now what is the length given? You see 2.45, then twice 2.45 divided by velocity 4.9. This is 4.9, this also is 4.9. What will be the value ultimately you people are getting? 1 second you will be getting. That means the fourth option which has been given as 1 second is going to be the correct option for this. Simply remember this equation. V is n lambda. N can be rewritten as 1 by time period. Therefore lambda by t is the corresponding equation for velocity one should take up here to solve this model question as such. Check the next one. That is question number 7. Two uniform stretched strings A and B made of steel are vibrating under the same tension. So tension value has been given equal. If the first overtone of A is equal to the second overtone of B, and if the radius of A is twice that of B, then the ratio of lengths in the strings will be how much? That is the concept. One thing you should understand, 1 by 2L root T by M. 1 by 2L root T by mu. This is the formula for frequency. Look at the other form of the same equation please. 1 by 2L you write as it is. This can be written as TL by M. Because mass per unit length we can write. That in other words we can write 1 by 2L root T into L by mass is volume into density. Volume into density means pi r square L into rho. L getting cancelled. What will be now left over? 1 by 2L root T by pi r square rho. That is the formula. But here you people can understand by reading the question, it is a tension that is constant he has mentioned. And 2 anyhow is constant we know. Rho anyhow is constant we know because both are made up of the same material, that is steel. What is pi anyhow is constant we know. Then what is the only thing you people are finding? L into r square. N is inversely proportional to L r square. That is the concept what he is talking about. Out of that, if n is constant once again, L is inversely proportional to r square you people have to take up. But how to take up this equation? Try to just understand this concept carefully. N for the first wire, it is in the first overtone. First overtone means second harmonic. So Na, I can write that one as 2 by, right, 2L root T by pi Ra square into rho. This is actually the case. And what about the second one he is talking about? Third overtone. That second one is second overtone. Second overtone means the third harmonic. 3 by 2 Lb root of T by pi Rb square into rho. Now you can cut this pi on both sides, rho on both sides, T on both sides. Everything gets cancelled over here. What is now left? You just check this one. 2 also you can cancel that one off. 1 by La Ra. Because Ra square under root coming out means it becomes Ra is equal to 3 by 2 Lb Rb. Now what is the question he is asking? Ratio of lengths he is asking simply. Ra is twice Rb he has given. Therefore this gets cancelled and you are left with 2. This 2 and this 2 anyhow gets cancelled. Then what will be La by Lb please? 1:3. what you will be getting, you just look at LA is to LB will now be equal to 1:3. So which option that is correct over there? Third option is going to be the correct answer for this question number 7 as such. But calculation wise, one should be a little careful, because second overtone, first overtone, like that is talking about. First overtone means a second harmonic, second overtone means third harmonic, and so on. Like that we people have to remember and check the things properly. Look at that next problem, that is question number 8. An argon pipe P1 closed at one end and containing a gas of density ρ1 is vibrating in its first harmonic. Another argon pipe P2 open at both ends and containing a gas of density ρ2 is vibrating in its third harmonic. Both the pipes are in resonance, that means their frequencies are equal with a given tuning fork. If the compressibility of gases is equal in both pipes, the ratio of lengths of P1 and P2 is how much? Assume the given gases to be monoatomic. That is the concept. This question has been asked in Eamcet recently, right? So what you should understand in this case is, he is talking about the very first one is P1, density is ρ1. It is vibrating in its first harmonic. Which pipe it is? An argon pipe closed. So first harmonic becomes V by 4L closed. That is the concept. But how to write this one? 1 by 4L root of this E by rho I should write. That rho is rho A. That's what has been given here. Or rho 1, that is what has been given here in the problem. I write that one as rho 1. So this is the first one. What about the second one, please? It is also in the first harmonic itself. He is talking another open pipe, right? Both open at both ends and containing a gas of density ρ2 is vibrating in its third harmonic. That is the concept what has been given. Third harmonic means 3 times V by 2L. L open I am talking about. So we can write this one directly this way. 3 by 2L open root of, what is V to be written? E by ρ2. That is the equation. When that fellow is talking about both are in resonance, means what? Both the frequencies are going to be equal. Come on, equate these two please. 1 by 4L closed, root of E by ρ1 is equal to 3 by 2L open, root of E by ρ2. E gets cancelled first. 2 cancels here twice. Now just cross multiply this one. In what way you can take up this one? 1 by 2L closed into root ρ1 is equal to 3 by L open root ρ2. That is the concept. Now he is asking you to find out ratio of lengths of P1 and P2. That means L closed by L open. I just want. That is going to be how much now? 1 by 6 root of ρ2 by ρ1. That is the equation what you are going to get. Now check this one carefully there please. 1 by 6 of ρ2 by ρ1, which is going to be the fourth option, that's going to be true. Once again check carefully. This is second overtone or third harmonic. This is first harmonic. This closed pipe, this open pipe. So that is a relation one should have in memory. Come to the next one, that is question number 9 in this case please. A sonometer wire has a length of 114 centimeter between two fixed ends. Where should two bridges be placed so as to divide the wire into 3 segments in centimeter whose fundamental frequencies are in the ratio 1:3:4. That is the concept. This type of a question has been asked several times at Eamcet. The simple logic for that one is N into L must be constant. This in fact is called the first law of vibrating strings. So what we can write now? N1 L1 is equal to N2 L2 is equal to N3 L3. Come on, equate these two first. What is the frequency ratio given? 1:3:4. So 1 into L1 is equal to 3 into L2. Then what will be L2 now? L1 by 3. Likewise 1 into L1 is equal to, the other ratio is 4. 4 into L3. Then L3 can be written as L1 by 4. But according to the given problem, L1 plus L2 plus L3 must be equal to 114 centimeter. That is the length that has been mentioned. So add these values please. L1 plus L1 by 3 plus L1 by 4 should be 114. That means this 12 if I take 12 L1 plus 4 L1 plus 3 L1 that is equal to 114. So 12 plus 4 16 plus 3 19 L1 by 12. 19 L1 by 12 is equal to 114. L1 will now be 114 into 12 by 19. Exactly you will be getting 72 centimeter. If L1 is 72 centimeter, what should be L2 now? L2 will be 72 by 3. How many times it just goes? 24 centimeter. What will be L3 now? It is going to be 72 by 4. How many times it goes? 18 centimeter, 18 times. So what are the three values of lengths now to be taken? 72 centimeter, 24 centimeter and 18 centimeter. Look at the fourth option please. 72, 24 and 18. These are the three corresponding values he has given for L1, L2 and L3 as such. Let us check the next number, question number 10 please. Three waves of equal frequency having amplitudes 10 millimeter, 4 millimeter and 7 millimeter arrive at a given point with successive phase difference pi by 2 radian. Let us understood pi by 2. The amplitude of the resultant wave is given by how much? Wonderful question. It is a very simple one. Only thing is three waves are entering to a point. One is coming this way, one is coming this way, one is coming this way. This difference is pi by 2. This difference also is pi by 2. What are the values given? You look at. This is 10 millimeter. This one is 4 millimeter. And this one should be 7 millimeter. That is the case. Now look at carefully. Are they not opposite by directions? Then what will be the resultant? 10 minus 7, which now becomes 3 millimeter. This 3 millimeter and 4 millimeter, are they not perpendicular to each other? Therefore, the resultant in this particular case is root of 3 square plus 4 square, which now is going to be 5 millimeter as such. A very simple question. Only thing you should understand is pi by 2 radian is going to be the successive phase difference that has been mentioned in the problem. So correct option for this one is the third option as such, which is 5 millimeter as such. Look at the next problem. Problem number 11. If the length of a stretched string is shortened by 40% and the tension is increased by 44%, then the ratio of the final and initial fundamental frequencies will be how much? Now we can all understand frequency is ratio he is asking. So N1 by N2 is equal to L2 by L1 under root T1 by T2. That is the formula. Tensions are varying and lengths are varying. Now how to write this one? Length is shortened by 40%. That is the point. So if I write L1 as it is, L2 should be written as L1 minus 40% of L1. Right? This is the value under root. If I take the total tension initially as a T1, it is increased by 44%. T1 plus 44% of T1. Then what can you write now in this case? You look at 100 minus 40, it is 60 by 100, L1 getting cancelled, root of, T gets cancelled over here, 100 by 144 you get. In fact, you can write this one 60 by 100 into 10 by 12. This goes 5 times, this 0 gets cancelled and this goes twice. So what is the ratio ultimately? 1:2. Check that option there please. 1:2 is the correct way, but he is asking the reverse order, you see, final to initial. I have calculated N1:N2, but his question is what is N2:N1? So what should be the correct option for us? 2:1. So very first option is going to be correct for us. That's question number 11. Let us check this next number, question number 12 as such. A tuning fork of frequency 340 Hz is vibrated just above a cylindrical tube of length 120 centimeter. Water is slowly poured in the tube. If the speed of sound in air is 340, then the minimum height of water required for resonance is. Even this type of a question also has got has been given in the previous Eamcet papers like. Now look at carefully, frequency is given 340 Hz. Speed of sound is given again 340 meter per second. Then you can understand lambda value will be 1 meter. So that is one area you have to take up. And of course, what is the question he is talking? Water is poured in. If the speed of sound in air is 340, minimum height of water required for resonance is how much? When lambda is this, we know for first resonance generally, right? For resonance, the general condition over here must be lambda by 4. So how much it should be? 25 centimeter. 25 centimeter where from? From the top. But he is not asking you that, from the bottom. So what will be the second resonance? 3 lambda by 4, that is 75 centimeter from the top. That means you people should understand it is also not going to be the case because it is not the minimum. So third resonance if I take 5 times lambda by 4, which is 125 centimeter. Actual length of the tube is given 120 centimeter only. So 125 is not possible. So what is the minimum possible thing over there? 75 centimeter. Therefore, what would be the height of water is the question. Total length is 120 minus 75. Whatever the value you are getting here, that is 45 centimeter, must be the minimum height of that water at which the resonance that is going to be possible. Means what? The second option is going to be true for this question number 12 as such. 45 centimeter is the minimum length or minimum height. Okay, check that next number. Question number 13. A segment of wire vibrates with a fundamental frequency of 450 Hz under a tension of 9 kg weight. The tension at which the fundamental frequency of the same wire becomes 900. Very simple question. 450 is given initial and 900 is given final. So definitely you can understand n is proportional to root t. Now n is to be doubled means tension should become 4 times. So 4 times the initial value. What is the initial value given? 9. So 4 times 9, right? 36 kg weight must now be the value. Even you can solve this one like this also. N1 by N2 is equal to root of T1 by T2. N1 is N or N1. N2 is twice N1 that has been given. Therefore, T1 by T2. This gets cancelled. So, T2 will now be 4 T1. So, how much will be your answer? Just 36 kg weight. Wherever that 36 has been given, you look at first option that has been given as 36 kilogram weight as such. So, that is the corresponding answer for this. Such model questions at Eamcet are not supposed to be worked out using formula this way. By look, you can finalize the answer there. Check that next number 14. Question number 14 as such. Look at that. An open pipe resonates to a frequency F1 and a closed pipe resonates to a frequency F2. If they are joined together to form a longer tube, then it will resonate to a frequency of. Neglect end correction. That is a concept what he is talking. First open pipe. What is F1 then? V by 2L1. What is F2 then? It is V by 4L2. Then what can we write? L1 is equal to V by 2F1. What will be L2 now? V by 4F2. That is the concept. Now he is talking about both are attached. Then what will be its actual length now? L1 plus L2. Another thing is this, open pipe and closed pipe when they are attached, ultimately that becomes a closed pipe. Then what will be the frequency now? V by 4 times L1 plus L2. Then what should we write? V by 4 times L1 plus L2. V by 2F1 plus V by 4F2. Just to simplify this total lot please. V by 4 into, you can take here 4F1 F2. Now of course this one 2F1. So 2F2 will be here plus this is F1 whole multiplied by V. Now this 4 gets cancelled, this V gets cancelled, reciprocate this one. F1 F2 by 2F2 plus F1. That must be the effective frequency of the system. Look at that one, F1 F2 by 2f2 plus f1. So first option that's tallied with that answer as such, whatever we have got. Check the next problem. Problem number 15 this time. The concept here is the length of sonometer wire is 90 centimeter. And the stationary wave setup in the wire is represented by an equation y is equal to 6 sin pi x by 30 cos 250t, where x and y are in centimeter and t is in second. Number of loops formed over there will be how much? That is the concept. Now look at that equation first of all. The equation over here is going to be y is equal to 6 sin, look at the equation carefully, it's given pi x by 30, okay, into cos, what is the other value that has been mentioned over there? 250t. This is a stationary wave equation, first of all you should understand. Now the question over here is, what is this pi by 30 now? It is to be called as wavelength. That means what you should write? Pi by 30 is 2 pi by lambda. Pi getting cancelled, lambda becomes now 60 centimeter. That is the concept first. The moment lambda is 60, a loop means what is its length? Is not the length equals to lambda by 2, please? So how many loops are formed in 90 centimeter long wire is the question. You can understand lambda by 2 will be 30 centimeter. That means one loop is possible. 2 lambda by 2 for the second loop, that should be 60 centimeter. So 2 loops are possible because the total length is 90. 3 lambda by 2 will now be 3 into 30, 90 centimeter. The length is 90 centimeter, therefore third loop also is possible. If I go for 4 lambda by 2, 120 centimeter I will get, which is not possible because the length is going to be 90 centimeter only. So how many loops are going to be formed over here? Simply 3 loops are going to be formed. Check that option number 4. It is exactly given as 3 loops as such. So this is the concept for this question number 15 as such. Look at the next one, that is question number 16 this time. Velocity of hydrogen at NTP is V. The velocity of sound in a mixture of hydrogen and oxygen in the ratio of 4:1 at NTP is how much? That is the concept. In fact, we all know very well, velocity is equal to under root gamma E by rho. Generally, we people used to write like that. And of course, you can take this rho as m also. That is m by v, mass per unit volume, like we can take up. You can even write the same as gamma p by rho and other things like. But what is the concept here? V1 by V2. That is the one what we have to take up. V1 by V2 is equal to root of molecular weight of the resultant mixture by molecular weight of the first gas that has been taken. What will now be the resultant? You can write N1 M1 plus N2 M2 whole divided by N1 plus N2. That is the formula. 4:1 he said, 4 times molecular weight of hydrogen plus 1 time that of oxygen by 5. So is it not 20 by 5? That's going to be 4, please. So can't you just write this one 4 by 1? That is simply 2. Then what will be V2 the question? It will be V1 by 2. If I take initial velocity as V, is it not simply V by 2 now? Check those options carefully. Fourth option is given as V by 2. So this is the formula one should take for calculating velocity in a gas, taking the density into consideration. Look at the next one, that is question number 17 as such. A sonometer is set on the floor of a lift. When the lift is at rest, the sonometer wire vibrates with fundamental frequency 256 Hz. When the lift goes up with an acceleration 9g by 16, the frequency of vibration of the same wire changes to what? That is the concept. In fact, we know that formula very well. N is directly proportional to root T. This also can be written N is proportional to root mg. In other words, N is proportional to root g. So how to rewrite this one now? N1 by N2 is equal to root of G1 by G2. G1 is G initially. G2 is G plus 9g by 16. That is the value mentioned. So how much it will now become? 16 by 25 under root. That means, is it not 4 by 5, please? So what will be n2 the question? It is 5 by 4 times n1. What is n1 that has been given? 256 it is given. 4 cancels 64 times. Right. So it is 320 heads must now be the corresponding answer. Look at that option number 2, which has been given as 320 heads for this question number 17 as such. Look at the next one, that is question number 18. In a resonating air column apparatus, first and second resonances are obtained at depth 22.7 centimeter and 70.2 centimeter. Then the third resonance will be obtained at a depth of what? That is the concept. You can all understand in the case of a resonating air column apparatus, L1 plus E must be lambda by 4. What is L1 that is given here? 22.7 plus E is equal to lambda by 4. That is the first resonance. What is the second one? L2 plus E must be 3 lambda by 4. That is 70.4 plus E is equal to 3 lambda by 4. That is your second equation. But what is this E called? End correction. Is it not L2 minus 3L1 by 2, please? That is 70.4 minus 3 times 22.7 by 2. Exactly you will be getting 1.05 centimeter. So end correction value is 1.05 centimeter. That you write it here. Then what will be lambda by 4 now? 22.7 plus 1.05. How much it will now be? 23.75. But what is his question? Where do you get the third resonance? That is the concept. Is it not L3 plus E now is equal to 5 lambda by 4? Then what will be L3 plus E means 1.05 is equal to 5 times. What is lambda by 4 we people have got? 23.75. Now L3 will now be 5 times 23.75 minus 1.05. If you simplify this one, exactly 117.7 centimeter you will be getting. That means the very first option that's going to be tallied with this for this question number 18 as such. Look at that next number, problem number 19. A sonometer wire of length L is plucked at a distance L by 8 from one end, then it vibrates with a minimum frequency N. L by 8 it is plucked, means definitely you should understand lambda 1 by 4 must be equal to L by 8. This goes twice, therefore lambda 1 will be L by 2. That is the first equation for you. Now what is the next one? If the same wire is plucked at a distance L by 6 from another end, the minimum frequency of its resonance is how much? Lambda by 4 this time, once again lambda 2 by 4 is going to be L by 6. Then what can we write? 2 times 2, 3 times 2. So lambda 2 is equal to L by, that is 2L by 3. That is going to be your second equation as such. But we know very well V is equal to N lambda. That is the concept. Now where from you people can get directly V is equal to N lambda, lambda 1 and lambda 2 are given over here. We can understand that velocity must be constant. So N1 by N2 must be equal to lambda 2 by lambda 1. That is 2L by 3 into 2 by L. You can write this one 4 by 3. Then what will be N2 the question? 3/4 of N. Look at those options carefully. 3N by 4. Where it is given, you check that one. Third option is going to be the correct option for this question number 19 as such. Look at that next question, that is question number 20 over here in this case. A uniform rope of length 20 meter and mass 5 kg is hanging vertically from a rigid support. A block of mass 4 kg is attached to the free end. The wavelength of the transverse wave pulse at the lower end of the rope is 0.04 meter. The wavelength of the same pulse as it reaches the top is going to be how much? Very simple concept. In fact, wavelength lambda 1 by lambda 2 is equal to T1 by T2. That is actually the concept under root. So what are the values he is giving you? You see there, lambda 1 is given 0.04. What will be the value of lambda 2? The question. What is the T1 here? T1 is given the weight of the body, that is 4 kg. As you move up, total value will be 9. So this becomes 2 by 3. Now what will be lambda 2 please? 0.06 meter you will be getting. Because this goes here 0.02 times. Cross multiplication gives you 0.06 meter, which is the very first option that's going to be true for this question number 20 as such. Look at the last number in this order please. Look at the 21st question. A cylindrical tube open at both ends has a fundamental frequency n in air. Open at both ends, that itself is a wonderful clue there. So n must be equal to V by 2L. That is the equation for an open pipe. The tube is dipped vertically into water so that 1/4 of it is immersed in water. This is the tube and it is now dipped in water. How much is inside? 1/4 is inside. That means how much is outside? 3/4 is outside and you have water till this extent. So the wave enters this way and leaves this way. Then can't you just understand this must be now lambda by 4 is equal to 3L by 4 over here. Then lambda must be equal to how much? 3L. That is the concept. What is the fundamental frequency? It is now V by lambda. How much it will be? V by 3L. But just look at this one carefully please. V by L, is it not 2N now? That one you write it here. 2N, right? V by L. In place of this V by L, 2N by 3. Look at those options carefully. Where do you have this 2N by 3? You look at second option is going to be the correct option for this question number 21. So this way, different model questions, whatever we have discussed based on the vibrating string of a sonometer, the open pipe, the closed pipe, and the basic equations of this one waves like a stationary wave, a progressive wave, and the relation between phase and path differences like that. This is the first part of this sound chapter what we people have taken up. We in fact are having a very important concept ahead of us, that is the concept of beats, Doppler effect, and the acoustics of buildings along with the concepts of echo formation. So these concepts in the very next session of our class we people are going to discuss about these topics. Right? And at the same time, in the final examination of Eamcet, we can expect 2 questions from wave motion. Certainly, both the questions are going to be formula oriented. And if you are a little cautious and careful about the formula of this chapter, certainly every one of you can score 2 marks from this chapter wave motion in the final examination as such. All the best. Thank you.